Bismillahirrahmanirrahim. Assalamu alaikum, dear guys. Mr. Atiq is here once again from science department. We have week 12 and in this week we are going to study chapter 22, section 3. This is the new section. Remember, the pages we are going to cover is ranges from 688 to 691. Remember, it seems to be like 3 preview things only, but this is like the most descriptive sections we are going to cover. Functional groups, okay, there are 5 to 6 functional groups we are going to study, and we are going to cover it. Listen it thoroughly, okay? Let's describe each and every one. Remember, these are just descriptive one, and you need to follow your own book as well, like for different things, for different stuff. Objectives. Define come to the previous topic. In the preview, objectives are there, functional groups are there, and classes of organic compounds are there. Okay, we are going to cover. Remember, functional group. Okay, remember these functional group we are going to study. Objectives: define, identify, and explain. Define like functional group and explain why functional group are important. Identify alcohols, alkyl halides, ethers, aldehydes, ketones, carboxylic acids, esters, amines based on the functional groups present in each of this chapter, okay, or in this section. Explain the relationship between the properties and structure of compounds and various functional groups. Functional groups. What is functional group? A functional group is an atom or group of atoms that is responsible for the specific properties of an organic compound. For example, if you are going like to use the functional group of any substance or of any kind of element, you can say it can like you can say abruptly change the properties of that thing. Understand? By removing anything, like for example we are studying the methane, removing of A in E by YL, it will give us what? Methyl. So methane has a different property and methyl has a different property as well. So functional group, the facility of the functional group is what? Like the advantage, you can say that it can change the specific properties of that substance. A given functional group undergoes the same types of chemical reactions in every molecule in which it is found. Of course, must be like this. Compounds that contain the same functional group can be classed together, okay, like for the acids, for the bases, all those things. Ons for the oxalics, understand, for the alkyl, like aldehydes, dehydes, like this, understand. While groups, methyl, ethyl, butyl, propyl, butyl, pentyl, like this. So they can be classified together. Of course, if they have the same functional group, they will be classified and together. Classes of organic compounds. A functional group gives an organic compound properties that are very different from those of the corresponding hydrocarbons. This is the function, okay? Like functional group give us what? Organic compounds properties that are very different. Of course, you included something new, okay? That's why the functional group can be used. The compounds in the table on the text slide all have 4 carbon atoms, but they have very different physical properties due to their different functional groups. Seems to be like 4 carbon atoms, but due to its physical structure or physical properties, it can give you what? Different properties because of their different functional groups. Okay, we have comparing classes of organic compounds. Look at butane, 1 butanol, butanoic acid, 2 butanone, diethyl ether. Understand? Diethyl ether. Structure formula for the butane is what? 1, 2, 3, 4 butane. Yes. Melting point is minus 138.4 Celsius. Boiling point is minus 0.5. Density is what? 0.5788. Okay, 1 butanol. Look at, because of this H or OH group, 1, 2, 3, 4, it becomes buta, but this is OH what? Butanol. Look at the properties, how it's just changing now. Minus 89.5, 117 boiling point, 0.8098. Butanoic acid similarly, look at acid, why? Double bonds came, okay, here. Butanone, look at C, O been attached here. Look at the rest is all same. Buta, 4, 1, 2, 3, 4. Understand? So this is 2, 1, 2. This is 2. This one 2 butanone. Look at the melting point. These are the properties. Yes, 79 and then 0.805 respectively for the diethyl ether as well. Look at this is 1 and this is 2. 1 2. So dia 1 2 dia. Ethyl 1 2 ethyl 1 2 ethyl. This is what? Diethyl 1 2. If you place it from here 1 from here, so it is what? 1 2 1 2. So this is 1 2 1 2 1 2. Diethyl ether. The properties are there as well. Common organic functional groups. Name, chemical symbols, naming suffix or prefix, examples, properties and uses. So easy. This is a complete gesture. This structure. Remember, these are the complete structure. If you are going to study just the properties, prefix, how they are going to change, example is there, chemical symbol is there. So there is no need for any description, though I included in the few slides by giving you like the ether, alcohols, aldehydes. But these are the main gist. You can get the knowledge from these things, okay? From this slide. Alcohol. Look at. This is the chemical symbol. OH must be attached. Okay? OL. Look at alcohol. OL. OL. Name suffix OL. What? OL. Like methanol. Methanol. Methane. A-N-E by OL. So methanol. Example is what? Look at 1 2 3 4. So this is iso, like same, propanol, 1 2 3, propane, yes, so propanol, 1, this is what? OH is attached, this OH, okay, it must be at the one end. So isopropanol, 1 2 3, propane, so this is what? Propanol, it will be known as what? Propanol, like propane, so propanol. Properties and uses. Some properties similar to water, able to form hydrogen bonds, useful, precursor, okay, precursors for many compounds, okay, precursors for many compounds, useful like to enhance the medical, like you can say the facilities or the abilities or the properties of different compounds, okay. Now come to the ether. O must be in between C and C, ether. Look at CH3 here and CH3 here, diethyl. Look at 1, this is 1 2 1 2. If you start from here 1 2 1 2, so diethyl 2 ether, CH3. This is the chemical symbol for it. Aldehydes as well, like in this, okay. Look at volatile solvents used in anesthetics or no hydrogen one. Anesthetics, what? Ether. Anesthesia, okay, unconsciousness. Common organic compounds continue. Look at organic acids, ketone and then amines. For the ketone, this is, remember, if you have these symbols now, you can put it from methane until decane. You can apply it, okay, there. If you know this chemical symbol, or if you know that how to change the prefix by including ATE, ONE, AMINE, amino, ine, azo. Understand? So these are the examples and the properties as well. Classes of organic compounds. Aldehydes, alkyl aldehydes, alkyl, look at alkane, so this is what? Triple bond will be here. Alkyl halides. Alkyl halides are organic compounds in which one or more halogen atoms, fluorine, chlorine, bromine, iodine, are substituted for one or more hydrogen atoms in a hydrocarbons. Aldehyde. Look at Teflon, okay. The non-stick coating on this pan is made up of Teflon, okay, and alkyl halide substance. Look at this one is what? Non-sticky one. So this is Teflon. Whenever you are going to buy any utensil for your kitchen, ask for the Teflon, okay, or it may be entitled there. If this Teflon is entitled there, it means like it is from the alkyl halides, and the property is what? The non-sticky one. It will not stick. So you can cook your egg, especially in the morning, or omelette, a non-sticky one. It will not stick to that pot or utensil. Classes of organic compounds. Ethers. Ethers are organic compounds in which two hydrocarbons groups are bonded to the same atoms of oxygen. General formula is what? ROR, where R represents hydrocarbon groups, either the same one as R or a different one. Ethers are not very reactive compounds and are relatively non-polar, by the way, okay. Ethers are commonly used as solvents. Classes of organic compounds: aldehydes and ketones. Aldehydes and ketones are often responsible for certain odors and flavors. Yeah, odors and flavors, good. Aldehydes, I just love these things. Look at this is cinnamon. This is like the raspberry or blackberry. Yeah, and these are the almonds, and this is what pure vanilla extracts as well. Wow, it will be so tasty. So these are the structure formula for these things. Look at iron, cinnamaldehyde. Look at from the cinnamon. Raspberry. Look at this raspberry ketone. I have a juice as well in my fridge here, refrigerator. Vanillin. Look at vanilla. So vanillin. This is what benzaldehyde. Benzaldehyde, like for the almonds. Amine. This is what batroxytoxinin. This Gabi is producing. Okay, look at the frog. I think this is from Australia. Yeah, I was watching the Sir David Attenborough video. This is what batroxytoxinin. Toxinin means what? Toxic. The poison dart frogs produces toxicamine, one of which is the beta-cortozinin. Beta-cortozinin. A. That kills nerve cells directly. Remember, the nitrogen atoms of the amine is showed in the red. Okay. Look at this frog. Belongs to, I think, Australia. Okay. Beta-cytoxinin A. Beta-cytoxinin A. Classes of organic compounds: carboxylic acids. Example of carboxylics are what? Acetic acid. Yes, we are taking. It is a sunnah as well. Okay, by taking vinegar. Citric acids present in Bertakal juice. You can say like different orange juice. Citric acids on lemon. You can say benzoic, propanoic, and sorbic acids used as preservatives. Okay, to keep the things for a long lasting time. You can use sorbic acids, propionic acid, and this is what benzoic acids. Carboxylic acids are much weaker than many inorganic acids. That's why it can keep the ability, or it can keep the quality, okay, or keep the lifetime, because it is a weaker, such as hydrochloric acids, sulfuric acid, and nitric acid. This is gonna kill you straight away. Hydrochloric acid and sulfuric as well, H2SO4. Wow, if it is concentrated, it can bust all of your bones into, it will melt your bones as well even. And nitric acid as well, HNO3. Esters. Wow. Related to foods, the esters in bananas can be synthesized and used as a flavoring. Imitation bananas extracts. Okay, it is present where, it is present. It is a tough protective layer. Look at how Allah subhanahu wa ta'ala created this banana, or just built this banana, a very definite esteric, you can say juice, or you can say the peel, or the skin. How Allah subhanahu wa ta'ala protect the banana seed inside. Okay, this is a tough coral sheet, or which is what known as ester, used for the dryness as well. Now, common odors, smell, and flavors of esters: ethyl butanoate, methyl salicylate, guanylyl formate, methyl anthranilate, and linyl acetate. These are the structure formula for this thing. Ethyl buta, so 4 will be there. Okay, look at, if you consider 1, 2, 3, 4 from here, or if you consider it what like from here, 1, 2, 3, 4. Understand? To give you what? Pineapple odor, then wintergreen oils, then rose. Wow, this one, guanylyl formate, good. It is presented what? In rose. Grape juice and jasmine as well. This one, benzene structure, physical structure, and lavender. This one we are using in our homes as a sprayer. This is what? Linyl acetate. This is the structure formula for that thing. Remember, by putting something into the main carbon or hydrocarbons, by changing the last suffix by different names, by different functional groups, locate, like for example alcohol, or look at oil, by giving them these kind of names, it will change the property. So functional groups are considered to be what? Gives an organic compounds properties that are very different from those of corresponding hydrocarbon. Is an atom or group of atoms that is responsible for specific properties of an organic compound. It can give organic compound. That's why most of the chemists in the laboratory, they are producing, or they are just like, you can say, inventing different kind of stuff for us to keep our food, to keep our homes safe. Okay, they are using for the different disinfectants. Understand? Just by changing in the laboratory the functional groups of any hydrocarbon or organic compound, so they can give us like different properties. Hope you will enjoy. And this was a very long, you can say a long section. You need to cover these things and just follow your book as well. Okay, by changing the things, changing the last word of any hydrocarbons, it can give you like different properties. So in the next week, inshallah, we will meet. Till then, fi aman Allah.